Hi guys, welcome to this page of the notes, and what we're going to do is we're just going to go ahead and now practice our objectives for this set of videos, which was to be able to perform operations with imaginary and complex numbers, so that actually the next 3 pages of the notes here just have additional problems for us to work through. And here's what I love. I would absolutely love at this point if you guys just go ahead, work ahead, try them on your own. At this point, hopefully you should be comfortable with both addition, subtraction, multiplication, and division, and then just come back and check to make sure that you get what I get, so that you know that you're doing them right. So here we go. Let's just jump into these, and we're going to fly through these next couple of example problems. I recognize that I have division, all right? Division, which means I need to multiply top and bottom by a complex conjugate, and please don't let this throw you off that my bottom number is purely imaginary, right? It doesn't have a real number associated with it. That's okay. I still need to multiply top and bottom by the conjugate, and since it's a plus 5i, we'll do minus 5i. So we're going to go multiply top and bottom by minus 5i minus 5i. Well, in the top, here we go. It's just a minus 5i, so I will simply multiply that minus 5i times both of these guys. And here we go. 4 times a minus 5i is going to be a minus 20i. And a minus 5i times an I would be a minus 5i squared. In the bottom, 5i times a minus 5i is going to be a minus 25i squared. Well, remember, I squared is equal to a negative 1. So here we go. Minus 20 times I. Minus 5 times a minus 1 would be a positive 5, so plus 5. And in the bottom, minus 25 times negative 1 would be a positive 25. Switch those guys so that I have 5 minus 20i, all divided by 25. Which is perfectly acceptable answer, except you should also be able to separate them and actually reduce the fractions, which it can be reduced. And here's what it's going to look like. 5 over 25 minus 20 over 25i, which actually is going to be, I pull a 5 out of both of those and I wind up with 1/5. Pull a, let's see, what can I pull out? I can pull a 5 out of both of those, and leaves me with 4/5 I. And actually, that is going to be the best answer. If you wanted to, you could rewrite it as 1 minus 4i over 5 if you wanted to go back to the combined fraction, but once you've gotten here, there's really no point in going back, so that's going to be your best answer, most simplified answer for that one. Let's try another one. Okay, once again, we are doing division, so we're going to multiply top and bottom by the complex conjugate, which in this case is going to be 3 minus 5i and a 3 minus 5i. In the top, I'm not foiling, I just simply need to distribute that through the parentheses, so I wind up with minus 6i and a plus 10i squared. In the bottom, 3 times 3 is going to be 9 minus 15i plus 15i minus 25i squared. Once again, it always should work out this way. Those middle terms drop out. You have an I squared in both the top and the bottom. You should always wind up with an I squared in the top and the bottom. Again, if you don't, you done goofed. Go back and figure out what you did wrong. Okay, the I squared is going to be a negative 1, which makes it a minus 10. That's the real part, so I'm going to put it in front. Minus 10 minus 6i. And then I'm going to have a 9 minus 25 times a minus 1, which would be a positive 25, which gives, which winds up giving me a positive 25 plus 9 would be 34. 34. And let's see if we can reduce this. I'm pretty sure we can. So we're going to wind up with 10, 34 minus 6, 34i. It looks like I can pull a 2 out of both of those, and I'm probably going to be able to pull a 2 out of both of those. So I'm going to wind up with, let's see, yeah, if I pull out a 2, 5/17, and minus, pull out a 2, 3/17. And that's going to be where you're going to want to leave it in simplified form like that, where 5 and 17, right, they don't have anything else in common I can pull out, and neither do 3 and 17. So that's as much as I can simplify it. Let's try a couple more. Let's see what we got on the next page. Okay, awesome. I got another one here where I'm going to have to do division of complex numbers. So let's go ahead and multiply top and bottom by the complex conjugate, which in this case is going to be 1 plus I over 1 plus, sorry, that's a weird I. Let me fix it. I am going to have to FOIL both the top and the bottom. 2 times 1, it's going to be 2 plus 2i plus I squared. In the bottom, 1 plus I minus an I squared. Middle terms drop out. That's going to be a negative 1. That's going to be a negative 1. So we wind up with 2 plus 3i minus 1. In the bottom, we wind up with 1 plus 1. It gives me 1 plus 3i all over 2, which is going to be 1/2 plus 3/2 I. Just that quick, right? Once you get the hang of these, they're really, really simple to multiply top and bottom by a complex conjugate, and then you just simply FOIL it out. Make sure you get those I squareds. You always should. Middle terms drop out. Replace the I squareds with negative 1s, and you got yourself your complex number. Let's see what we've got here next. Awesome, addition and subtraction of complex numbers. So remember, you're going to add and subtract the real parts, add and subtract the imaginary parts. It's just like combining like terms. So let's go ahead and check this out. I got to distribute that minus sign. Don't forget. So I'm going to have 4 minus 3i plus 7 plus 2i plus 3 plus 4i. Right? Distribute that minus sign. Negative times a negative is going to be positive, and negative times a negative is also going to be positive. Let's put the real parts together and put the imaginary parts together since I've got a couple of them. I'm going to have 4 plus 7 plus 3. Those are my real parts. And then I'm going to have a negative 3i plus 2i plus 4i. Those are all my imaginary parts. And here's what I wind up with. 4 plus 7 is 11. Plus 3, 12, 13, 14. And then I have, let's see, 2 and 4 would be 6i, 6i minus 3i, positive 3i. Just like that. Combining like terms when it comes to addition and subtraction. Let's keep going. I got a couple more for you. Awesome. It looks like what we're going to be doing here in this one is foiling. So let's go ahead and try another foiling one. Multiply the first. 3 times 4 is going to be 12. 4 times 6 is, of course, 24, so plus 24i. Negative 5 times 3 would be minus 15i. And then negative 5 and 6 would be a negative 30. I squared. But remember, I squared is a negative 1, so this just simply becomes 12. 24i and negative 15i should become a 9i. And then the negative 30 and the minus 1 would be a plus 30. All right, so 12 and 30 should be 42. Right, 12 plus 30 would be 42, and I've got my plus 9i. I got my complex number coming from foiling those binomials. I believe this is the last one I got here in this note set, and it is division. So let's go ahead and work our way through this one. Multiply top and bottom by the complex conjugate. Since it's a plus 2i, multiply top and bottom by 4 minus 2i. This one's going to be a little bit of work. I got to FOIL the top and the bottom, so let's see how this goes. 2 times 4 is going to be 8. 2 times a negative, so that's going to be a minus 4i, minus 12i, and then we're going to wind up with a plus 6i squared. 4 times 4 is going to be 16. I'm going to wind up with a negative 8i, a plus 8i, and a minus 4i squared. Okay, well those I squareds are negative 1s, and the middle terms drop out just like they should. If they don't, you done goofed. Combine like terms in the top. Minus 12 and a minus 4 should be a minus 16. A positive 6 times a negative 1 would be a minus 6. In the bottom, I have 16. A negative 4 times a negative 1 would be a positive 4. Okay, I got a positive 8 and a negative 6, which leaves me with a positive 2. All over 20. I'm definitely going to be able to reduce that. And we wind up with, looks like I'm going to get 1/10. In the bottom, 4, right? I can pull out a 4, which is going to leave me with 4/5. 4/5. Hi. And you got yourself a complex number. Guys, thanks so much for joining me for this set of videos. Hopefully at this point you feel pretty comfortable working with imaginary numbers, both where they come from. No longer is the square root of a negative number undefined, but now we have a definition for it. The square root of a negative one we call I. And then being able to use those complex numbers, which you were introduced here in this section, to do addition of complex numbers, subtraction of complex numbers, multiplication of complex numbers, and division of complex numbers. Again, thank you so much for joining me for this set of videos, and I'll see you guys the next time.